So in this series of videos, we're going to talk about properties of logarithms. Now remember that exponential functions have their own properties, and exponential and log functions are inverses of each other. So the properties for exponents are going to be quite similar to the properties for logs. You'll see similarities in them. Let's start by looking at the product rule that you see here. The product rule for log says log base b of argument m times n. I can rewrite that as log base b of the argument portion m plus log base b of n. So similarly to exponential properties, when we are multiplying the argument, we can write it as the sum of two separate logs, each of these having the same base though. Okay, we have a similar property when we talk about the quotient rule. So this says log base b of m divided by n. So order matters for subtraction. This breaks out into log base b of the first argument, or the numerator, minus log base b of the second argument, or the denominator. Now, you can see here that we have these rules. We'll go over the next one, the power rule. The power rule is shown for you here, log base b of m raised to the p power. So the power rule for logs says that we're going to bring that p down to the front and multiply it times the log. So here you can see p times log base b of m. Remember when we had the exponent rule and we had a power to a power, we ended up multiplying those powers, and that's similar to what we're doing here. Finally, we have the inverse rule. The inverse rule is going to say if I have log base b with the argument having a base b raised to the x power, those bases cancel and we are left with just whatever the power was. Similarly, if I have b, a base of b, raised to log b, those b's have to be the same, and that's going to give me just the argument x. So this is a very handy rule when we are simplifying expressions. Notice that when we either expand these, so if we take something that's condensed and write it in this expanded form, they all carry the same base, log base. I can move either from a condensed form into an expanded form, or if I start with something that's expanded, I can condense it in this way also. So be sure that you have these properties written down for the rest of the chapter. Now the first set of examples that we're going to use are actually going to use the inverse property that you see up here. So I have two examples down here, and I want to use those properties of logs to find the exact value of my expression, and I can do this without using a calculator. So here I have log base 4 of 20 minus log base 4 of 5. Notice that I have the same base for both of these expressions, and I am subtracting. So if we kind of scroll back up here, subtraction with the same bases implies the quotient rule. In other words, I can rewrite that expression below as a single log function or a single log expression with division of the arguments. So this becomes log base 4 of the first term, or the first argument, divided by the second argument. Simplifying 20 over 5, we get log 4 of 4. Now remember that we have the inverse rule that says the log base b of b to the x is simply the exponent there. So this 4 that's in the argument position is raised to an understood 1, meaning that the 4 that's the base here and this 4, which is the base of the argument, are the same, so the answer to this whole problem is really just 1. So we used the quotient rule and the inverse property to simplify that expression. Let's try that again over here. I have the natural log of e to the negative 16. Remember that when we see the natural log, The natural log is really shorthand for log base e. So we have natural log, which stands for log base e, of the argument e to the negative 16. Again, using the inverse property, when I have the base of the log and the base of the argument the same, that's equal to the exponent of negative 16. Okay, so that's how we can kind of use properties of logs to find the exact value of each one of our expressions.